I've given lots of feedback. I did not finish the prayer models. I'll try to finish that during lunch, but probably not until this afternoon. All right. So, looking here, do homes with metal roofs get worse cell service than homes with shingled roofs? Ben and Jerry are neighbors and own an ice cream business together. Ben has a metal roof on his home and Jerry has a shingled roof. They select a random set, like the normal black roofs that you've seen, those are shingles. Yeah, those are called shingles. They select a random sample of 50 employees and randomly assign them to come to a party at either Ben's house or Jerry's house. When they arrive, Ben and Jerry ask them about their cell phone signal strength. Was this an observational study or an experiment? What do you think?
Observational studies.
Why do you think observational?
There's no treatment first of all, and there's nobody like being forced into the do one and one.
Wait.
Sounds like Madeline and Raina really want to push back on that. Madeline, what you got?
It's an experiment because the treatment is like these houses.
So the two different houses had two different types of roofs, right? And there's another important detail with that. There's what? There's a random assignment to those houses, to the roofs, right? So that random assignment and the treatment of the types of roofs makes this an experiment. So a random assignment to the treatment of the type of roof makes this an experiment. It's a random assignment of treatments. Now I will say, the random assignment doesn't make it an experiment, but the treatments do, and the random assignment to treatments together. It's both those pieces together, okay?
So,
Yep.
in the question, can I, not like 100% sure, but when I see the word assign, can I assume that is an experiment?
Make sure that it's random assigned, they're randomly assigning to treatments, but yes, the phrase random assignment we're going to go into more today is associated with treatments and experiments. Okay. All right, 2A, or 2, a study showed that one variable that strongly correlates with another student academic success is the number of books that the family has in their home. Researchers, P.S. that's actually true when you, I know like 50 years in the future because it feels like it's that far away, but when you do go to have kids, make sure you have lots of books and you read them. We read with Alex, I think, 2 or 3 books almost every night. He has a whole bookshelf already. We have a couple bookshelves, like reading matters. Anyways. I mean, we're just trying to make him think. All right, so researchers randomly selected 100 students and measured their academic success as well as counted the number of books their family had in their home. Is this an observational study or an experiment?
Observational study.
Observational study. They did not assign the individuals to the number of books they had in the home, right? They were not assigned to any treatments. But are there still explanatory and response variables? Yes, and I need y'all to be careful. I need y'all to pay attention to this. Just because there are not treatments does not mean there's not explanatory and response variables. If there's not treatments, what's the problem? It's not just that there's not experiment. There's something that's a problem that treatments kind of fixes or addresses or reduces. Raina?
You cannot compare the results. Yeah.
That's part of it. Say it again. It's all about confounding. Remember, guys, the idea of treatments and especially of randomly assigning to treatments is reducing confounding, right? There are other things at play. Because here's the thing. There's very clearly, there's data upon data that shows the more books that someone has in their home, the higher academic success that student has. Those things are correlated together. But what other variables is related to the number of books and can explain their academic success?
Their IQ? No. What?
But is IQ related necessarily to how many books they have in the home?
No.
No, but there's something else. Raina?
The type of books they have and who they own it, it might be just like their dad's book or something.
But again, this just says books in the home, so it's not who owns the books or anything like that. What else?
How many books you can afford?
Say it again.
How many books you can afford?
Okay, so if you can afford more books, what does that say about your family?
You're more affluent.
You're more affluent. Is affluence correlated to or related to academic success as well?
Yes, it's a correlation.
Definitely. Like, if you haven't ever seen the data, that's fine, but like, if you have never seen the data, students who come from higher income families have higher academic success overall. It's not guaranteed for everybody, but that's the typical. Like, when you look at just even Hillcrest High School, students who are in honors and AP courses typically come from higher SES, higher socioeconomic status. Whereas students that are in regular classes are typically not from as wealthy of families. That's just the reality. And again, it's not every individual, but that's the overall norm, okay? And so that's where I'm really big on education, because I think a good education can level the playing field for everybody. But I'm still working on doing what I can here at Hillcrest. But what else can relate to, is associated with how many books someone has in their home and is predictive of academic success? Right?
I'm not sure about this, but genre of books?
Not necessarily, because again, like, here's the thing. Does the genre of books predict academic success? Not necessarily. Does the genre of books even really determine the number of books? Guys, there's a big one y'all are missing here. Kinsey?
Like their parents' academic success.
Okay, generally, someone who has higher levels of academic success also is going to have what at the house? More books, right? Textbooks, but just more books in general. People who have more academic success typically have more books in the house. And if the parents typically have more academic success, then that pushes their kids to have more academic success, right? So that's a confounding variable, is like, what's the parent's education level, things like that. So here's the thing, and so Rana, you're identifying things that are related to, I think, that are just variables that are somehow related. But it needs to be associated with, it's a completely different variable, associated with the explanatory and predicts the response variable. The ones that you were given weren't necessarily, like the genre of book doesn't necessarily predict academic
I
success.
think didn't have the concept.
It's that predict part that I think you're missing. Yeah, but it's good. Like, here's the thing. If you didn't say those things out loud, then I never would have realized that was where you're having an issue, and I wouldn't be able to explain it, right? So, guys, don't be afraid of mistakes. I don't think I've said this to this group at all yet, but I do want to say this right here and right now, because this is a conversation. So, like, one, like with Alex, we're reading with him as much as possible. We want him to love books, and he does at this point. And we're going to try to maintain that hype train. But one of the things that we also talk with Alex, and we're already doing this from when he was 2 on, especially became prevalent when we had to teach him how to put his clothes on himself and potty training, things like that. Like, he came home one day from school, like early in potty training, and like he was afraid to go to the toilet. And I think he had a really, really, really bad day, or a couple of bad days with the potty training at school. And like, I could tell something was wrong. And so I sat down and I talked with him, and he's like two years old and maybe 3 months at that point. So somewhere around, I don't know, 27 months. And so it's hard to talk to someone that age, but I was like, hey buddy, what's wrong? And he just kind of like, I don't wanna. And I was like, okay, did you have a bad day at school with the potty? And he goes, yeah. And I go, did it feel bad? And he goes, yeah. I was like, did you mess up? Yeah. And like, it was like all these things, like this is what was affecting him. And I go, Alex, I need you to hear me on something. It's okay to make mistakes if you learn from them. So like, don't be scared of mistakes. And so like, a thing that has become a pervasive conversation is, one, I ask him, hey buddy, don't forget, like, you made a mistake, but what do mistakes make you? And he goes, bigger and stronger. And then he's afraid, he had a hard time figuring out how to put on clothes, which I tell you what, like, never would have thought it'd be a struggle to teach a 2.5-year-old how to put on clothes. Apparently it's normal. But he would have breakdowns over it, and I would have to remind him, hey buddy, is it okay if things are hard? And he would look at us for like a month straight and be like, no. And I'm like, no buddy, I need you to hear me. And every time I would respond like, yes, it's okay if things are hard, because hard things make us bigger and stronger. I need y'all to go ahead and take on that mindset and attitude, because we're going to make mistakes in an AP class. Things are going to get hard in an AP class, but hard things make us bigger and stronger academically, and mistakes make us bigger and stronger academically. Don't be afraid of that, okay? What's up, Emerson? Yeah. You were trying to skip class, I got you. Found band more important? I'm not sure. You can jump in with the queens. All right. Sorry, all that to say, what are the explanatory variables in this check your understanding?
The quantity of books.
The quantity of books, that is explaining the response of
Academics.
academic success, right? Now, have we shown causation?
No.
No, why not? Because there's confounds and there were no
Treatment.
treatments, right, to reduce the effects of those confounds. So no, we have not shown causation, we only have correlation. We know they're related, we just don't fully know how yet. Okay, so C, explain clearly why such a study cannot establish a cause and effect relationship. Oh, well, we already addressed C. So, why can we not establish a cause and effect relationship? There are no
Treatment.
treatments, right? So we can't establish cause and effect. And there are confounds, right? What was an example of a confound? Academic success of parents, socioeconomic status of the family, those things are related. This is the check your understanding from 4.5. So, does that help recap that 4.5 a little bit? Yes? No? Maybe so?
Yes.
Now,
Why do you look so happy with your answer? You shouldn't be happy about that. Great, you were very.
alright, I'm going to pass back the DYUs in just a minute, but I do need to answer that homework question first. So let's look at 4.5D.
2D?
2D, that's what I said.
Yep.
It's not literally what I said, but it's fine.
Yeah.
And 4.5 homework.
See what, Star?
D.
She's talking about the.
I thought.
I
see what?
What?
Okay, right here. So yeah, so Ray, this is kind of what your struggle with that last bit is, so this will actually help a lot. So does reading books help you live longer? A study was conducted on a cohort of 3,635 participants who answered questions about their reading habits via telephone survey. Researcher followed up with the participants 12 years later and concluded that book readers experienced a 20% reduction in risk of mortality over the 12 years of follow-up compared to non-book readers. So, D, I will say is this, is based heavily on C. So what's a possible confound, and we'll build 2D off of C, but what's a possible confound on book reading and risk of mortality?
Disease.
That read book would generally be shorter and better to like not die.
Okay, so hold on to that one. We're coming back to Raina. What were you about to say?
What I wrote is genetic, health issue, environment, living pattern, and diet.
So here's the thing. So you listed a whole bunch of variables, right?
Yeah.
But you need to show how those variables are connected to, because remember, it needs to be associated with the explanatory and predictive of the response, right? So Charlie, what was the one, how explain that depth again. So Raina, just listen to the depth of like how he connects these things.
Someone who has a lot of books in their home likely be smarter and therefore not have a little longer.
So, someone who has more books in their home, right? That's my explanatory variable. Also, probably has a higher academic success, right? That's not a variable of interest here, but someone who has higher academic success or is more intelligent also probably knows a healthier way to live and how to stay alive longer, right? Does anyone know of another potential confound here?
What was the compound that you just said?
You were saying the intelligence, right? So intelligence is related to books, how much you read, but it is also predictive of whether you can stay alive or not. Yes, Kinsey?
Like money?
Money, right? People who read more typically have what? More money. And if you have more money, you can pay for medicine, you can buy better food, things like that that can help you live longer, right? So money is another really good confound in this situation because it's related to how much you read and it is predictive of how long you live. Yes?
If where they live has a higher crime rate?
So I'm not going to disagree with that if you explain why. Well,
Because okay, well that kind of ties back into wealth, so never mind.
it ties back into what?
Wealth.
I mean, yes, but yes, it does, but like that is another route you could take, so that's not a bad thing. Typically, people who live in higher crime rates get to do what less? Read less. And if you live somewhere that has a higher crime rate, you're more likely to die. So that's not bad, right? But also, it is related to wealth, right? If you live somewhere in a higher crime rate, you probably have less money. So it's not that it's not related. That's totally fine. Okay. Ray, does that give you a healthier understanding of all those things? Cool.
Yeah, it's kind of, I don't think I considered the response very much.
Right, and you have to consider the prediction of the response. You have to show how it is associated with explanatory and predicts the response. It's not just another
So
variable.
considering that I can predict what response variable will be.
Okay. Let's see what I have planned on here. So I do have a plan. Let's see. Wait, is that the right day? No, that was yesterday.
No, I lost.
Okay. Oh yeah, quick note about textbook and prayer models. I don't think, most of us don't have our textbook with us, do we?
I know you did that when you told us about the
Correct, yeah. I know. Sophie, you have yours with you though, right? Can I see it real quick? So Sophie and I were just talking about this earlier, and I just want to show this to make it clear. When I say AP exam tips, was that on 252? Is that the page I was looking at?
I thought it was 50.
Something like that? Okay. So when I say AP exam tips, there's a literal box that will say AP exam tips. You can't necessarily write all of that down. Now, if you want an extra sheet of paper of a prayer model, you can get it. But those are things that you definitively need because these are things that are going to be expected on the AP exam that you do correctly. Okay? Do also pay attention to stuff that is in red. And I'm going to talk about this one more later because that is an exclamation point next to it saying bias is not just bad luck in one sample. When you talk about bias, and I need to be more clear about this I think in the future, bias is not misrepresenting the population once. We're going to talk more about that in the future. So pay attention to anything that is in red. It is actually a good idea to read through and get all the big stuff, not just definitions. So please pay attention to that. It says AP exam tips. It has all that in there.
I think you told us about the red bias can be constantly written.
Right, and so that's one of the things, and again, like, that's something I talked about once. I've mentioned it one more time, I think, since then, so not enough, but it's also in the book. Like, it's a highlighted thing in the book. It's something you have to pay attention to, and some of us explained it really, really well, but use those things. Now, I'm going to give you a quick heads up, because we're going to go over some details of the DYU before we get into experiments. There's not going to be a single number on here. There's no grade on it yet. I will put a grade into power schools because I have to, but anyone got to guess why I don't have a grade on here?
Because you don't want to discourage us.
Okay?
It's our first one.
Because it was bad already.
So see, that's why I want you to hold on to this. One, it's not just because it's the first one. I will never put a grade on these. I might mark stuff right or wrong, but what does it look like there's a whole lot of on this? Words, meaning there's a whole lot of what?
Non-numbers.
Corrections and feedback. Even when you got some stuff right, okay, I gave feedback because the point of this assessment is so that I can see where you are and I can figure out a way to help you move forward in your understanding. So I will not put grades on this because as soon as I put a grade on it, that's all that you focus on and you miss the feedback, okay? So what I will say is there are places where you'll notice an E, P, or an I. In AP statistics, an E means that you got something essentially correct. It doesn't mean it was perfect, but it was essentially correct. A P means partially correct, and an I means incorrect. And so those are the ones you really need to pay attention to. But that's what they use on the free response, and so that's what I'm going to use on grading a good chunk in this class and always on the free response. All right, so there's a handful of these that I'm going to go over to make sure that I clearly address some issues that I saw. Some of you will even have notes at the top. Don't let me forget to talk about this, Lorelei. And again, it's not about whether you did well or not. One of the things I think that drove students crazy last year was that I didn't just tell them the grade. And they were like, I don't know what I did. And then they would look at the actual grade and be like, oh, that was fine. It's like, yeah, it was. And then Andrew's skipping today. And then Phoebe. I know. Alright, so, again, lots of feedback, it's so that you can grow and improve. Now, pause for a second, I need us to hear this. I'm gonna talk about a handful of things. What I'm gonna ask you to do over the weekend is to pour over the rest of the things that we don't talk about and see what questions you need to ask to start Monday. Okay? Because hopefully the feedback I've given you is enough that you go, ooh, I know how to fix this mistake. But if there's not, if you still have a question, ask that first thing on Monday. Does that make sense? Okay. So the big ones I want to talk about here is number 4. Hey guys, we got to pay attention to number 4, right here. Increasing sample size will generally eliminate bias in a sample. Phenomenal job. I'm pointing out that eliminate is wrong. We can only do what to bias? Reduce bias. But a lot of us miss the increasing sample size part. Because here's the thing. If you look at Crazy in Love and you keep picking the 5 words that you want to pick, it doesn't matter how large the sample size is. Which type of words are you going to pick?
The same.
The bigger ones, right? So there's still under coverage or selection bias. Increasing sample size with a bad sampling method still gives you what?
More bias.
Bad data still gives you bias. I cannot emphasize that enough. We got to learn from this. Increasing sample size with a bad sampling method is still biased. A bad sampling method is a bad sampling method. It does not matter how much you increase that sample size. Okay? So, increasing sample size will actually never do anything to bias. And we're going to talk more about what bias is on the backside. But please hold on to that. Increasing sample size will never do anything to bias. Okay? Number 6, I understand, and so I just want to address this because I think I made a mistake in explaining this. We've talked heavily about making an inference from a sample to a population, but guys, this word generalize is equivalent in statistics to the idea of an inference. When you generalize from a sample to a population, you're making an inference. So like when I looked here, and we said, hey, I think the sample mean is 4.74 letters per word, I'm making a prediction about the population. I'm generalizing to the population. Okay? So when you make an inference, that's equivalent to making a generalization. Now, we haven't talked, by the way, because it does already say inferential statistics. We haven't talked what inferential statistics are yet. We'll talk about that later. But what's the actual problem with number 6?
It needs to be.
It is not an experiment,
It's
it's
an observational study.
Yeah, we need to notice experiments are not about generalizing to the population. Experiments are all about what?
Causation.
Causation, cause and effect. So guys, experiments are about cause and effect. Observational studies generalize to a population or inference about the population. Does that make sense? I know how to correct that detail. Okay. Yes, Brandon?
In matching, in 11, number 11,
Well, hold on. On number 11, so I'm going to cover these questions right now. If you have a question, if you look over it over the weekend, you have a question, then let me know then at first thing on Monday. Right? So I'm going to cover some specific ones first, okay? Just because we've got to get more into experiments today. So, number 14, this is a big one. And this is, I know that I said it clearly once, but once is not enough, so that's my fault. It is in the textbook. It's actually one of the AP exam tips that I need us to pay attention to. But what does the term bias mean in statistics? When we say bias, that's not one sample missing the mark. Because here's the thing. Was this simple random sample biased methodology?
No.
Yes.
I mean, the center was the true mean, roughly, wasn't it? When we did random samplings down here, was our method biased or was it pretty accurate to the mean?
Yeah.
It's pretty accurate. Now, here's the thing. Is that single data point accurate to the mean?
No.
No. Is this single data point accurate to the mean? No. So why is this method unbiased, but I'm getting such varying responses?
Variation.
There is variation, okay, so I want to make this more clear. This is in the book, I can't remember if I used this term, and that's my bad if I didn't. Sampling variability. What this says is that different samples, I have it actually right there. Different samples will produce what? Different results. There is always going to be sampling variability, okay? So the question is not just sampling variability. The question is my method consistently wrong? There's always going to be sampling variability. So in bias, which I just covered this in my Algebra 2 class, the sampling methods are biased. That means the samples will consistently yield poor estimates of the population. Notice, their center of the data was way off, right? The center of this data set was pretty far off. The center of this data set was pretty darn close. So bias is when the samples, repeated sampling will consistently miss the mark. So let me say it that way. Bias is when repeated sampling will consistently miss
Is it
the
just
mark.
like repeating sampling, like repeating bad sampling?
Say that one more time.
Is it just simply like the sampling, like it's like all?
The sampling, anything about the sampling method is bad. So if you ask questions in a way that it influences the responses, response bias, that's bad sampling method, right? Using a convenience sample, that's bad sampling method, right? So any of those types of bias or those types of bad samples will yield sampling that's consistently wrong, okay? I'm going to talk a little bit more about that in a second, right? Now, here's the thing. Why is bias an issue when collecting data?
Because it doesn't represent the population.
So it doesn't accurately represent the population. Emerson, what were you saying? Same thing, okay. There's another, and when we say it doesn't consistently represent the population, why is that a problem?
Because
you're trying to
what
find
the
out.
goal, the goal of the.
So our goal is to make an inference about the population. Don't forget that. Now I do need to point this out. We need to be careful, okay? What about the sample are we trying to make an inference about for the population? What from the sample are we trying to make an inference about in the population? A statistic to make an inference about the parameter. I need to be more clear about that. That's on me. So I'll go ahead and say that. That one's on me. But remember, when we say that the sampling will consistently miss the mark, our estimate from the sample, the statistic, is not, excuse me, the statistic is not representing the population, or the parameter, right? So when we say, why is bias an issue? So the statistic, or statistics from the sample are not accurately predicting the parameter of the population. And so that's about the center, right? We want the center of our statistics to be the parameter. We want the center of our statistics to be the parameter. Okay? We're trying to make an inference about the population. But what about the population? That's on me. We're trying to make an inference about the parameter, whatever that parameter is. And there's lots of different parameters out there. We're going to talk about means, we're going to talk about population proportions, well, population mean, population proportion, population standard deviation, population medians, etc. Okay? Now, I think everybody got this part. What is necessary to reduce the effects of bias?
Randomization.
Randomization.
RNG.
Okay. Now, but here's the thing, not an RNG, just randomization. Are there other randomizing elements out there?
Yes.
Yes. What's one that was mentioned in the textbook?
Stratified.
That's a type of random sampling, but other than random number generators, RNGs, what else is out there that we could use to get a random sample?
Systematic.
So there's random digit tables also, right? Like you can get random numbers from a random digit table. If you don't recall that, you need to go back to the textbook because it's there. I'm never going to use that method, but it is a possibility. They do say, it's like you can do it on the free response. I never would. I would always use random number generator. Allegedly, according to the author of the textbook, they have once upon a time asked a question about a random digit table on multiple choice question. I've never heard of actually seen that, but that's what they claim. So I don't waste the time on that. You can also, and I mentioned this the other day, each of the individuals you could write on a sheet of paper or on a slip of paper, put it into a hat, shake it all up, and draw names out of a hat. I hate that method because the description for that method is really hard to get right on the AP exam. The other issue I have for it is, who in the heck is writing everything on an identical slip of paper, putting it into a hat, and then drawing it out? Is that realistic?
No.
Yes.
No.
It's more fun.
Then you do the fun thing. I'm going to stick with my random number generator, all right? But does this help us understand the question for number 14 better? Okay. All right, 16 is where I saw some of the bigger issues that I want to address, okay? Number 16, first things first, okay? Some of us said a convenience sample here. And I let it go because here's the thing. Is this an easy way to collect data? 100%. But be careful because when we say a convenience sample, it's still the researchers who are selecting the sample. In a convenience sample, the researchers are still selecting the sample. That's not what was happening here. What did the social media influencer do?
She posted on her story.
She put it on her story, she put it on her social media platform, and then anybody who chose to could respond. Notice she didn't give anybody the survey or the question. She didn't choose anybody. She just put it out there in the ether and said, hey, whoever wants to respond can.
It's a volunteer.
Volunteer sample. That's a volunteer sample. So if you just put it out there and people can self-select to engage in the survey, that's a volunteer sample. Yes? Sophie?
You put next to online, but it's also under coverage. Why would it also be?
So hold on to that, because here's the thing, and that's one of the things. Remember, there's a type of sample, and then there's the type of bias. Under coverage is a type of what? Bias. So I'm going to talk about the types of bias in a second. The type of sample, though, is a volunteer sample. Now, volunteer samples always result in volunteer response bias. Does that make sense? So the volunteer sample does always result in volunteer response bias. Now you need to put it in context. Say again.
So if there was a question on the test with a bias in the sample, would we have to put that?
On the AP exam, I think, if I remember correctly, I've never seen it where you have to put more than one. As long as you correctly identify one source of bias, you're good. And so I will point this out. Some of us, so first off, there's volunteer response bias. You got to talk about what that actually means in context. But a lot of us said that there was response bias. But we did not describe the response bias correctly here. When we say response bias, what does that actually mean? It could be the question was worded badly, but what else could it? In general, it just means the question was presented in a way
That would influence
the response. So it could be worded badly. But remember how we looked at that firefighter going around town, like him dressed up in his fire uniform? Like, that's going to make you say, yeah, I want to give you money, right? It's influencing the results. So what up here could have influenced the results? Well, like, where's the response bias? Because there is an example.
She influenced herself asking.
Kind of.
I wrote that it's because she can see the results
Okay.
right away.
Okay.
It could be that like maybe your name shows.
Okay, so maybe your name is shown when you vote. Kinsey, what are you saying?
That's what.
Okay. there's some of y'all that wrote response bias, and I said that I would definitely accept it. Can y'all look at that and see where I might have said that and share that
How
out?
is she influencing response?
What's up?
How so?
Did you do the response? That was a different. Let me talk about what you put on that A in just a second. Okay. All right. Yeah, so that's what we're gonna talk about in a second. I'm just focusing on the response bias. Just like, how could there be a response bias here?
I mean, she asked if they would, or she was their favorite.
Yeah, am I your favorite influencer? And it's on her story. That's making, there's pressure on people to say, yes, you're my favorite. Or not answer, right? Like, there is pressure by her wording it that way. If she had said, who is your favorite influencer, there is less pressure to say, yes, you're my favorite. So that wording pressures or pushes people into saying yes. Okay? Or if they're not going to say yes, they don't respond. Right? So you could talk about non-response bias there, right? Actually, it wouldn't be non-response. That'd be voluntary response. So, okay? Now, can I see what you put on that, Madeline? Because here's something I want y'all to hear. Because Madeline did earn an E on this, and she did not actually talk about did not name a type of bias. What she put was, she put the question on the platform for 24 hours, no sample group was chosen, mostly just people that love her would respond or even follow her, right? And so what she has done is she has talked about how it's biased, that the group that is voting is different than the group who's not. Because remember, at the end of the day, when we talk about bias, there are the types of bias that we address, but then what is bias? The group or the data I have is different from what is true. So what Madeline has addressed is, hey, the people who are on her social media and will see it there in those 24 hours are her biggest fans. Other people who don't see it are the ones who don't like her as much. Especially if it's like 24 hours, right? If it's there for 24 hours and then gone, diehards, they're gonna see it, right? People that might like someone else a little bit more, they're not gonna see it necessarily in those 24 hours. So when we say bias here, or explain how it might lead to bias, you need to keep in mind, how is the sample different? So sample survey different from those not included. So there is response bias, etc. And so, Sophie, I made the note on yours, and this applies into B, undercoverage. Who is she undercovering? Who is she not getting data from? People that don't follow her, right? Who else? People who don't have social media or don't care about social media. People in general who aren't the diehards, right? So like there's a huge chunk of people that she's not actually getting data from. The response bias, or the voluntary response bias would play into that undercoverage, right? Because you're not going to respond if you, the people who respond, let's say it this way, either love her or what?
Hate her.
Or hate her. People that are kind of like, meh, they're not going to respond, right? So the people that are meh, you're not going to get because of this survey. Yes, Raina?
And the answer B, I just said it is estimated because blah, blah, blah. But what you're saying is, it's under, I have to put this with why it's undercovered.
Well, there's under coverage of the people who don't care as much.
Would that also mean that it's overestimated? Because they're
Well, that's not the right wording, so hold on to that. Because under coverage is selection bias. We're not getting a group of people. But what you're thinking about is D here. Do you, or B, do you think the estimate found in her sample will be higher or lower than the true percent? So here's what I want you to think. The statistic, because I wrote this on someone's paper so I don't forget. The statistic is what, 94%? The parameter. Do you think that number is higher or lower than the parameter?
It's higher than.
That's higher than the parameter, greater than, right? Writing this out helps me visualize, because you can flip the wording in this question. So the estimate in her sample will be greater or higher than the true percent, right, the parameter. But it could have been the question, do you think the parameter is higher or lower? By drawing something like this out, you can clearly see the parameter is what? Is lower than that estimate. So be careful on the direction of that wording. I think this can help address that problem. So, and then you have to explain. Remember, this explanation needs to tie back into your bias. The people who are meh don't respond, so I think that the parameter is actually lower than the estimate we got. All right, when we come back, we're going to move quickly through some experiments, which means we'll have to finish experiments on Monday. Okay. Yeah, I don't have time right now in the middle of class, but I can walk and talk with you. What you got? Like, do you need to look at the DYU to ask your questions? Okay. Try to get up here early and from lunch, and I'll try to answer them right away so that you can get those answers. Okay. Anybody do a different way? I said should probably stop the camera before I forget.
They just gotta like stand around.
Alright. So, we are getting more into experimental design today. We've already addressed a good chunk of the components of an experiment. And so, the components of an experiment. Thanks for cleaning that. That's like the opposite of what most students do, and I really appreciate it. Okay.
No, I saw him draw it some more.
What?
I saw him draw on it some more.
No, don't do that. Don't do that. Don't draw on my calculators. They're expensive pieces of technology. Okay, so we've got the components of an experiment, and when I say components of an experiment, I am talking about the explanatory variables, the response variables, the treatments, the sample, the population, all of those different things, okay? And I believe, if I remember correctly, in the textbook, it literally talks about the components in that way. And then there's the elements of a well-designed experiment, and that's what we're about to get into very heavily. So what do we need to do with our experiment, with our treatments, to make sure that we are making what inference well? What's the inference for an experiment?
Statistical.
Inference for an experiment.
Causal relation.
Causal relation of a cause and effect, right? So, whenever we are talking about experiments, I'm there. We're talking about experiments, we got cause and effect, and we need to make sure that we have a good inference. So what do we have to reduce in an experiment?
Compounds.
Not bias, compounds. Remember, bias prevents us from making an inference from?
Studies.
A statistic on the parameter.
So a statistic or from the sample to the
Parameter.
parameter of the population. Sorry, I don't know what you said, I didn't hear. But the whole idea is samples to populations, statistics to parameters. That's, and be careful, I will say this, those are observational studies and surveys, but an experiment is just another type of study. So, experiments are studies. You just said studies earlier, not observational studies. Yep. Okay. So foundation, we've already addressed treatments, experimental units. We hit that the other day, right?
I don't think we did.
No, we didn't.
I don't remember that.
No.
Yeah, I was saying, it was in the quick notes that you should have looked at. So remember, the experimental units are just the individuals the treatments are applied to. That's another component of an experiment, right? So the individuals the treatments are applied to, so experimental units. And I will point out, if those experimental units are human beings, and we know what we call those,
Subjects.
Subjects, yep, that's exactly right. So, the experimental units are humans, we call them subjects. I think now we have finally hit everything on here. Is there anything on this foundation that you're just looking at that term and you're like, I don't know? Sure, I can go through
And how much let's get the turkey off me.
Hold on, Rhea. Is someone already talking? Yes.
I'm like,
Retrospective is data that already exists, so stuff from the past or I just collected, so it's still technically in the past, but just collected. Prospective is when you follow the subjects or the individuals into the future. Yeah. Yes, Raina?
Oh, yeah, I think it's basic.
Okay, yeah. All right. So, what is wrong with these experiments? So Mr. Wilcox, that's Luke Wilcox who designed this, is trying out a new beard oil to make his beard grow faster for No Shave November. Notice most people do this as Unit 4, I don't get it, or Unit 3. For No Shave November, at the end of November, his beard is 3 inches longer. He concludes that since his beard grew 3 inches, the beard oil must work. I want y'all to at least do 1A and B together. There's not really a stop, is there? No. Do 1A and B together. Just add your groups, and we'll come back together and talk about it in just a couple minutes.
He didn't try it without the beard oil for a month.
I should just let it continue running. But so, what is wrong with this experiment? What's wrong with what Mr. Wilcox did? Go for it, Ian.
he didn't test, well, for one, he didn't test to see how his beard would grow without the oil being used.
Okay. So one thing that's wrong with it is did not test. Well, so let's actually consider this. Does he have a treatment?
Yes,
What is the treatment?
the beard oil.
He does have a treatment. He has a beard oil that he is applying to the individual, right? So he did apply a treatment. Notice it does say what is wrong with this experiment. This is an experiment with a treatment, right? It's just not a good experiment. Yeah, it's not a good experiment, right? So he did not, what was the wording used?
He did not test to see how his beard would grow without the oil.
So did not test to see how, that was used, how the beard grows without the oil. So what would this treatment be called if we are not using the oil to compare against?
A negative control.
Not a negative control. That's not a term in statistics.
We learned it. Oh, I'm thinking of biology.
Oh, that might be it. I would say you could look at the proficiency scales. Raina, you did find something in the book you're thinking.
What was the question?
What would be this not testing to testing to see how the beard grows without the oil? What would we call that?
Would it not be the control?
Control group.
That would be a control group. Remember, do we care about bias in an experiment?
No.
No. So this is a control group, right? So a control group is what we compare against. A control group has no active what? Treatments, right? It's a baseline. The control group has no active treatments, it's baseline.
It's the thing that doesn't change.
Say again?
It's the thing that doesn't change. It's not getting one, it's a treatment.
Yeah, the only reason I say be careful with that language is not changing can mean a lot of different things in statistics. So it'd just be better to, it doesn't get an active treatment. Huh?
It's not going to the treatment.
There you go. It doesn't get an sorry, I have to be careful with that. It doesn't get an active treatment. It does have a treatment. What's the treatment?
No oil.
No oil, right? It goes without the beard oil, so that's still a treatment. And so, yeah, that's a problem. Okay, so what could be done to improve this experiment?
Grow his beard for a month without using the oil.
So-
Compare.
Grow beard for a month
Without using the oil. With a beard oil.
without beard oil to compare results.
Beard oil.
Okay? Alright, so grow the beard for a month without the beard oil to compare results. Do notice, we're not doing one or the other, we have to do both so that we can do what at the end?
Make a causal relationship, have a causal,
No, at the end of this, so we can what?
compare results.
So we can compare results. Yeah. We are looking for a causal relationship, cause and effect, right? But that's the big thing there, okay? Is there anything else that you can think of that we could quickly maybe do to improve this experiment here?
Shave at the start.
Say it, bear.
Okay, so each time, which I wasn't planning on talking about that here, this might come up in a second, okay? So, shave at the beginning
At the first one.
of each trial, okay? So the first of the month, and I will say this, you don't have to do a clean shave, it could be just get it to the same length, right? Anyone know what we would call this idea of making sure in both trials that it starts at the same spot?
Control variable.
Close, not, you're very close to what we call it in stats. Yeah, probably. I will say this, you might, there is something you could look at that might have a term that might
Oh,
help.
a direct control.
It would be considered direct control. Specifically, and here's why we call it direct control, it'd be direct control of what?
The beard.
Beard.
The beard.
But what about the beard? Like, why would we
It's
need
a
that?
road.
It'll be like in control of the hairs.
The beard length could, the starting beard length could be a what?
Quicker growth. I don't know.
See, I don't want it to be an independent variable. Am I concerned, do I want where the beard starts to
No.
impact my results?
Oh, it's like the
No.
co-founding.
It's a confound, yes.
Oh.
Right? What's the issue in an experiment? Confound, so it's a direct control of confounds. When you can identify a confound that you can, yes, he is getting these.
Look at.
What was it?
Sorry, I meant to submit digitally, totally forgot, but there you go. He's alright. Shave at the beginning of each trial, or at least make sure they're all the same. Yes, sir.
Ian asked what a direct control is.
Yeah, I was gonna ask you that. You
So-
go over that?
When you keep things the same.
Did you just answer that?
Well, he might have found the word, but, so one, I will say that you can find more detail in the textbook. I will put it at the end with the quick notes. But direct control is when you keep a confound, a potential confound, because you don't know if it is, but a potential confound the same. Okay? Alright, so you keep a potential confound the same. Alright, anything else you think we could do to improve this experiment?
I have no clue what you're saying.
November's already passed by now.
Well, yeah.
Do it in the same month.
Okay, how could you do it in the same month?
By waiting.
Well, you can do it
Waiting
in
a year.
winter.
Waiting a year?
You can like, it's easier to have like the tape down.
Well, I wouldn't go that far, but I mean, could you give half your beard the oil and half your beard not oil, and then you can compare? That'd be real interesting, right? Okay, so, yeah, so that is, hold on to that idea. We're gonna come back to that one in a second. That's actually a really important one called a matched pairs design. Because here's the thing. Well, here's the thing. Like, we could test my beard versus, who's another coach here? Or,
Kenny.
I think
Coach
nobody
Haddon.
does it.
no one else has a beard?
McKinney.
Oh, Coach McKinney, Coach McKinney.
So I will point this out, in acknowledging this thing, I would say there's another confound in comparing like my beard to McKinney's beard. Anyone know?
Because of the core, his hair is coarser.
I would say, yeah, typically white people and black people grow beards differently. So that would be a consideration, so that might be a confound in that situation. Are there no other male teachers that grow beards?
Actually.
Okay, so I will say this, but so I guess it would work out the same. The reality is if you compare my beard growth versus House's beard growth or against McKinney's beard growth, there's the confound of my genetics versus their genetics, right? But how do you account for that?
You
You
have.
do a matched pairs, you do
Yourself.
half of my beard one way, the other half a different way. Half of McKinney's beard with the oil and half without the oil, right? So it's called blocking, we'll talk about that later. Okay, but those are all good improvements. There's one big thing that y'all are missing.
Make sure they get the same amount of sleep.
Same amount.
That would be under the idea of direct control though.
Same amount of oil.
Okay, same amount of oil would again be direct control, right? You're taking something and you're making sure it's the same, a potential compound, keeping it the same. How about this? Go ahead.
Such thing as indirect control?
No. How about this? There's a couple of more things, I will point this out. If I have is it possible that I have just like a weirdly phenomenal month of beard growth with the oil, but then and that was just natural, and then the next month my beard doesn't naturally grow that much?
Yes.
Okay, so what could we do to make sure I don't just have one data point?
Record throughout the month.
Do it multiple times, right? Replicate, right? So what can we do? We could
Repeat.
Yeah, we can repeat the experiment. You're not really repeating the experiment, you're just doing multiple trials. It's one experiment, right? You can repeat an experiment. So multiple trials with each treatment, right? So multiple months. And what did I say that's called?
Unmatched pair.
Oh,
Unmatched pair.
block.
Blocking.
Oh. Repeated.
Repetition.
Yo, you know that you have a proficiency scale that has all of these terms on there.
Replication.
Yes.
Replication.
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 Oh.
Wow, guys, did you know it's replication? It's wild.
Why are you so late on everything?
I know, I heard you too. Alright, replication. Alright, let me see if there's anything I'm forgetting on this really quickly. I think that's all I got.
It's hot in here.
Okay. Yep. Alright, so here are some things, right? Replication, direct control, having a control group. So these are all things that would improve this experiment. They're not the only things we can do, but those are big things that we could do to improve this experiment. You all good with those things? That makes sense? They logical?
I watch the YouTube video.
What do I need to re-explain?
Star. Well, you said we're gonna
So-
go through the match.
Yeah, so guys, please hear me clearly. Y'all, you came up with something that is touching on something else we'll talk about later, so I went in and talked about it a little bit. But the reality, I'll explain it more later. Don't sweat it. But literally, I want you to think, we are repeating here, right? So what are we going to call that repetition? Doing multiple of the same trial. Replication. You're replicating it. You're doing it multiple times. And in general, like when we talk about drug trials with medicine, do we want to just do one trial where someone gets the medicine and someone doesn't? No, that's not strong evidence, right? But if we do lots of times with the drug and lots of times without the drug, then we are collecting significantly more evidence. All right? So, yeah, try number 2 now. Work through these a couple of minutes and then we'll come back and discuss. That's cute.
Contractor.
You should have forced that.
No, this is why it's an experiment.
What do you think is wrong with it? I'm considered that they were trying, they don't have.
No, but
control.
isn't that children?
But I
Yeah.
don't think this is quite.
Yeah, they were choosing which group they were gonna be in.
That's not random.
It's not random.
Yeah. He said they,
They weren't.
Watch this people.
So what are y'all thinking?
It's not random. Decide shopping. 2 options.
So is that what y'all were thinking?
You don't get options, bro.
But y'all are in a crew. We need to be talking. Alright? Come on, let's talk a little bit, I'm gonna come back.
Wait,
So what's the issue?
what we did is switch off.
Yeah, it's.
Well,
Wait,
and
it's
so
not
here's the
random, it's all
thing,
the lazy people.
and you're right, but it's beyond that. If he just offered, right? There's not random assignment of what? Or assignment, period. It's not even random assignment, there's no assignment of what?
All the good
Right, there's no treatments, you just get to sign up. Right, there's still an explanatory variable, but there's no treatment, that's the bigger issue. Random assignment, we're gonna come back to later.
It's not even an experiment.
It should be pointed right here. Yeah.
I just did.
Dude, one of the videos I caught everything.
No, it's good, yeah. The second half of that is really what I need to focus on, right? So the first half is really good, but again, this idea there's no treatment, that's kind of the key. Okay, keep it going, think about me.
Right, it's not random, because all the lazy people.
They're not assigned.
Because
I
all
will
the
say
lazy
this.
people are gonna choose the relaxed workout, and all the muscle people are gonna choose the rigorous one.
So random's not a problem yet.
Oh.
I'm gonna.
No, they're not assigned.
They're not assigned to treatments.
There's no.
So what is wrong with this experiment? Like first and foremost, like if we're gonna talk about an experiment, we gotta have assignment to treatments. We can worry about randomizing later.
I think we're.
But if there's no treatments, we cannot in any way, shape, or form establish cause and effect. What you were talking about is 100% right, but we do want to address like, oh, there's no treatment. Lazy people are gonna choose this one, harder workers are gonna choose this one. Yes?
Can there be bias in assigning treatments?
No, it's not gonna be biased in assigning. You just have to remember, like, the idea of treatments is establishing cause and effect, so the only issue there is confounds. There is bias in our selection process. Okay.
I
This
don't
one
like
was
content.
walking on Stairmaster for an hour.
What?
No, for 10 minutes. 10 minutes, I'm.
But try focusing on B after you write about A.
Level 7.
Hey guys, make sure we're moving on to B and C. By the way, I do want to point out, because I didn't get to talk about it earlier, but I need you to remember, anytime there's a random process, what three things do you always have to clearly
Label,
communicate?
identify,
Label,
generate,
and select.
For this one.
Now, for an experiment, we aren't going to select, we are going to assign. But it's a three-step process that you have to clearly communicate. Label, generate, and select or now assign. So let's get through B and C. All right, so what's the problem we were seeing in 2A?
I'm gonna write down what I said, then you can just look at it.
From 1 to 120. Oh, wait.
You're good. They weren't assigned to what?
I get it because I'm a theater kid. I know that kind of stuff.
So you're using really, really good context. I need you to put a stats term with that context. They were not assigned to what?
60.
Right. So take what you're saying, but you also need to call it what it is. It's a treatment, right? They weren't assigned to treatments of the soccer workout or not the soccer workout, right? So or whatever. What is it, right?
Track.
Track, that one. Yeah, track. I got distracted by soccer. It's literally, I was like, oh, soccer. And then, you know. But it's the same thing, right? Like, there's not assignment to those treatments of the rigorous strength building workout or a relaxed workout of resistance stretching. Yeah. Okay, so move on to B. Yes,
I
right.
just kind of followed the sample that like, this is the one that I did for homework, you know, that we showed here.
Yeah.
So it would be fine to do it like this.
And I would even just describe like this.
Just like this.
Be careful, I wouldn't do that. Just randomly generate 60 unique identifiers and then go to here and I'll explain why to that later.
So you're not gonna tell me right now?
No, I'm not gonna tell you right now.
Identifiers and assign those.
Label the athletes. One thing I would say is label each athlete with a unique number 1 to 120. Just to make sure, because here's the thing, it's goofy, I know, but the AP exams has had it where like they didn't make it clear that each individual has their own number.
You can talk like a little louder.
then you don't get full credit. Like,
So like,
Right.
for responding,
And then,
identify.
now, be careful, you say generate
The-
60
And
what?
assign those 60.
But that's not clear communication. How are you gonna get your 60 random numbers?
Okay.
With a random number generator or a random digit table or something
Okay.
like that, right?
This
And
is-
you don't have to put
I-
the
I
1 to
don't
20
like
there,
that.
because you're,
Even more.
well, actually you do. Randomly generate 60 unique numbers.
It's like how we do it.
No.
They require that.
I like it when they
Yes.
Yeah.
Keep on. All right, so right here, A, what is wrong with this experiment?
It doesn't have a treatment.
There's no assigning of treatments.
Okay, there are no treatments, right? There's, or no assignment to treatments.
Which means it's not even an experiment.
So non-experiment, so we cannot establish what?
Wait, are the
Causation.
treatments not?
There is treatment, but it's like not being compliant.
Well, here's the thing, there's not really treatments unless, treatments implies that you are told to do something. There are explanatory variables, whether you do the rigorous strength building workout or the stretching workout, there's explanatory variable there, right? There's levels to it, but they don't become treatments until a researcher assigns it. Okay, so by just literally saying there are no treatments, and I would put context, right? There are no treatments, you've already established the idea that they weren't assigned to do something. So the word treatments implies that, okay? All right, describe an appropriate method they could use to randomly assign. If you need to, write out those 3 words to start you off so that you don't forget anything, or a 1, 2, 3, something. So when we say label, what do we mean?
Label
each
the
individual
numbers
person.
that correspond
Grade.
to the athletes.
So label each individual athlete
Is it good?
with what? With a unique
Number.
identifier or number. So do not forget, you can't just say label them. You have to have a unique identifier 1 to 120.
So context.
Yeah, so I mean the athlete covers that.
Yep.
Right? So then generate.
60
Generate
numbers,
number
randomly
generator.
60 numbers.
How do you need to be more clear about how you're getting those random numbers.
Generate using an RNG.
So generate 60 unique numbers.
Numbers. I just said 2 times, but you said it might be not.
But so yeah, hold off on that. I will say this, and I'm glad that you put this down, Ethan, because it made me realize I haven't addressed this, and I need to make sure I do. Generate 60 unique numbers between what? 1 and 120. It's goofy because you're like, I just said 1 to 120, but I've literally heard people who read the AP exam and other things, like when I was reading, say, oh, if you don't say it's 1 to 120, you could generate 60 unique numbers from 240 to 300. And I'm like, no one means that, Gina, like, come on. But you have to say it. So generate 60 unique numbers between 1 and 120, but what's the issue I still have?
You don't have like a.
Using an RNG.
Using a random number generator. Or what else could you use?
Oh, bucket in a hat.
A random digit table. The bucket and the hat can work, but I would use the table or random number generator. Now also, I actually have an issue here. What is it?
Assign. It
Yep.
should be assigned.
So don't forget, we go to assign with an experiment. So assign those.
Those.
Whose number is
Those
generated?
Those
Number
corresponding, those
generated.
correspond.
So those athletes with, we should say assign athletes with those identifiers. To what?
To relaxed workout and rigorous workout.
But we only have 60, so I can't assign them to relaxed workout and to a rigorous workout.
To one of the workouts.
So to one of the workouts, but you have to clearly communicate. Doesn't matter which one?
One strength workout.
Okay, so I assign athletes with those identifiers to the strength workout. Done.
So just
Except
like
not
that,
really.
Just like that was okay, then you just apply the other to
No, we're done with this. Now what do I need to do?
Now,
the. Do that again.
then put
Do
the
I need
rest
to
of
do it
the
again?
next stretch workout.
The rest get the stretch workout. We've already gotten 60 of them with the strength, right? So what are the other 60 gonna get?
The relax.
The rest workout. So you don't have to do this twice, right? Yes, Emerson.
How would you explain like the
Don't. I'm not gonna waste time right now. We can talk about that at another time. I'll think about when we can talk about it. We can talk about it. I just wouldn't, okay? Now, so I'm glad you asked that question. If you do not then say assign the rest to stretching,
You get dropped down from an E to a P.
you will get a P instead of an E. That's assuming that you are going to get an E, right? If you get a P, that drops you to an I. Now, it is important to recognize that there are times when you can have more than 2 treatments, okay? So in that context, you have to label each individual with a unique identifier 1 to 120, generate, or let's say 1 to 180. Let's say we had 3 treatments, okay? 1 to 180, generate 60 unique numbers between 1 and 180 using a random number generator, assign them to treatment 1. Then, generate 60 more unique numbers that aren't repeating, assign them to treatment 2, the rest get treatment 3.
So is it a number 3?
It's just like depends.
It just depends on how many treatments you have, right? So if you have more than 2 treatments, you have to go through a couple iterations.
So
Yes?
you said generate more than it does in the concept of first 60, so the generating part is included in number 3 if there's multiple treatments.
Alright, so what do you think the benefit of random assignment is?
It ensures that there are appropriate amounts of treatment
How you
to the
can,
staff.
That's the replication.
pull teammates of different levels into each group.
Okay, so we could there be different quality of teammates and they are now split up into the 2 treatment groups?
Yeah.
Okay.
Each group has like the really good people and the really bad people.
Right, so by not letting them self-select into those treatments or assign the good people to one treatment, the bad people to the other treatment, there's that. Star, you had your hand up second.
Decreases the confounding variables.
And it decreases, and the way we usually say it is reduces, right? So this reduces the effects of confounding. Yeah. So we reduce the effect of confounding. For example, the confound of some people are just better athletes. We now evenly split it up. It could be that some people are harder workers than others. I heard someone say that earlier. By randomly assigning, you are essentially distributing those potential confounding variables, which reduces the effect, right? So you reduce the effect of confounding by evenly, through randomness, right? By evenly distributing characteristics, or let's just say confounding variable values, yeah, or confounding variables. I think someone had their hand up. If you want to ask a question while I'm writing. Yes.
Can you explain the difference between, I mean, there's a difference, but the
Just say it.
causal and
Correlation. Correlation just means they're related. Causation means one is causing the other. Remember, I gave the example yesterday of as ice cream sales increase, so do the number of shark attacks. Those are correlated. Like, there's a relationship between them. But does increasing ice cream sales cause people to get bitten by sharks? No. Okay? So that's not a causation. So a correlation just means they are somehow related. But causation means one causes the other. So like in this case, those 2 treatments, is it possible that the strength building workout does cause the athletes to get faster?
Possibly.
Possibly, right? No matter what, there is a correlation here. There's a correlation, we see it, but without an experiment, I cannot make a statement about causation. Yes,
In
Raina?
an experiment, so can I say the causation is response variable and and can I say that statement, or is it?
Say that one more time.
In experiment, can I say the causation is a response variable?
No, the treatment or the explanatory variable, the factor, is causing the response. So there has to be an explanatory and a response. That's where the causation shows.
I was just confused about, well, if you already have a term called response variable, why would you really have a thing called causation?
Well, because the response still, you can have an explanatory and response when there is a correlation, but that doesn't necessarily mean that there's causation. You still have to establish that. So you can have an explanatory and a response, okay? Depending on the way you define it.
So
But it doesn't necessarily guarantee causation unless you have treatments. Yes, Dixie?
Are you gonna like, I don't know if this like relates to this, but correlation.
So that's gonna come up when we talk about bivariate data.
Cause like, what is this stuff like, unless in psychology at UA,
Yeah.
like the correlation and,
Probably talk about Pearson's correlation or,
That one example that you used, like, the shark attack.
yeah, that's a positive correlation. We'll talk about that with bivariate data, yep. In 2 units. Alright, number 3, we gotta move a little bit quicker. On a recent test day, an AP stats teacher wanted to determine if smart pills would improve grades. The students walked into class, they were randomly assigned a pill that said either smart pill or sugar pill on it. The test scores were significantly higher for the group of students that took the smart pill. What is wrong with this experiment?
It's late, they know which one it is.
Kids, teachers giving kids drugs. Obviously that's a problem, but say that again.
There's no, they're not, the subjects aren't blind.
Okay, so there, we need to talk about blinding, right? So what is happening here? The students with the,
They're choosing it.
no, they're not choosing, she randomly assigned students with the smart pill what?
Got smarter.
Are smarter.
Are they smarter?
Well,
They're all.
Their test scores are higher, but like,
It's a placebo.
there was
They
what?
what?
Yeah.
They think they're getting smarter, right? There's a placebo effect, right? So students with the smart pill think they are smarter, and that is a placebo effect, or it's possible. I will say that, we don't actually know if it's a placebo yet, so we'll say possibly a placebo.
Possible placebo.
So here's the thing, if you believe that you can, is that going to
Yes.
is that going to cause you to maybe work a little bit harder or do a little bit better?
Yeah.
Like,
Like confidence.
yeah, confidence matters, right? So I'm not about this idea of manifesting your destiny because that's stupid, but I am all about believing in yourself does help you be successful because you're going to work harder, you're going to believe in it, you're going to be confident in your answers, right? So the belief, how you think about it, matters, right? And if you're given the sugar pill, you're like, well, I'm just my normal self, but man, I got this smart pill, I'm ready to go, baby. I'm gonna crush it. They don't really exist, but you know, what's up, Brandon?
So why does this possibly placebo affect badly in experiment?
Why what?
The statement that you just wrote, why is it a wrong thing in the experiment?
Well, because here's the thing, is it actually the pill that's making them smarter, or is it just them thinking that they're smarter?
So what is that wrong about it? Doesn't,
Because I don't know if it's the pill, or if it's just they think that they're smarter, so they do better, right? So that's the idea of a placebo effect, right? So what could be done to improve this experiment? Oh, so that is a placebo, not possibly a placebo. Well, we don't know for sure, that yes, possibly a placebo. All right, so what do we do?
We can.
Okay, so remove labels.
Eden, what are you doing right there?
From pills. Now, you don't know if you're getting the smart pill or not, right? So removing the labels can do that. What else could improve this experiment? Someone mentioned it earlier.
Make them blind.
Make a blind,
I mentioned, no, that was me.
okay? So blind, because here's the thing, if you remove the labels, that's good, but if you still then tell someone, hey, I'm giving you the smart pill, and I'm giving you the dumb pill, that's going to impact things. I know, a sugar pill, okay? But that's the thing, right? So if we tell them still, even without removing the labels, that still affects results, right? So what do we mean by blind?
They're not aware of what they're able to be
Not tell
aware. They aren't aware of what they're
individuals.
So don't tell them don't tell students who got which pill, okay? All right, so we want to blind the students so they don't know who got which pill.
Green. Black pill.
I think we have a good term.
Okay. Now, the teacher's trying to collect this data, right? Trying to do this research. But what if there was like a TA that was giving out the pills and didn't tell the teacher who was getting which pill? What would we call that then? That would be called a double blind. This currently is a single blind because how many of the participants don't know? Just one. Will do. So there's single blind, but if both the subjects and the researchers don't know, then it is a double blind. Now it's also possible that the subjects know and the researchers don't know, and then that would be called a
Single blind.
It would go back to being a single blind. Remember, single blind just means one of them doesn't know. Double blind means they both don't know who has the treatment. Yes, Raina?
Is a double blind, it has a bad effect on experiment necessarily?
No, I think double blinding is actually usually better, but sometimes it's impossible to have a double blind.
It's like
So-
a census?
Well, no, because that'd be an observational study usually. Like, if I'm trying to do research on how a medicine versus just a reduced calorie diet versus a, what am I looking for? A exercise regimen affects someone's cholesterol, I can't lie to someone and tell them if they have the exercise regimen or not. They would know. Versus the calorie deficit, etc. So like in that case, the subject would have to know, but the researcher doesn't necessarily have to know. Someone else, other than the researcher, could assign those treatments. The researcher doesn't know, but the subjects do.
And that will be important points on AP exam.
You need to know single versus double blinds, yes. Again, time. Say again.
If we don't,
I'm going to, here we go, for the sake of time, big ideas that I need us to know. Learning target number 1, a well-designed experiment has to have comparison. We addressed that, we suggested it earlier, but you have to have comparison of 2 or more treatments. You don't have treatments, you don't have 2 or more, not going to work out very well. You have to have random assignment. Why do you have to have random assignment? To reduce confounds, right? Remember that random assignment for sure will filter out some of the confounds. We will learn about other ways to filter out confounds on Monday. And then we're going to have replication, right? We have to have more than one in each treatment group, and direct control is where we keep other variables constant, okay? Do not forget, label, randomize, or generate, and assign. And then placebo effect, when a fake treatment works, makes someone think that they're smarter. And then we have our stuff about blinding here. So we got, what, 2 more minutes? Let's see if I can use those 2 minutes effectively. Anyone think I can? I think it's possible.
Is placebo?
So go ahead and plan to do this, check your understanding. I'll say this, I will work through this, check your understanding, and do a video for it, and share it with y'all, maybe email a link to the YouTube video. So I want to quickly go back to this. We're going back to the SAT prep class. Yeah, we don't have time for this, but I will ask that you do, I'm trying to think of, at least do number 1. Yeah, numbers 1 and 2. I want y'all to attempt this so we can start without, so numbers 1 and 2, is this 4.7? I think we just finished 4.7.
It's 4.7.
So attempt numbers 1 and 2. I will point out, I don't like this right here. anyone know that issue I have right there?
You can't eliminate. You can never eliminate a problem.
Can't eliminate,
Wait.
well, no, I lied, in this one you can. Yep. So, notice they're not talking about eliminating confounds, they are eliminating a problem, they are worried that random assignment could potentially put all of the seniors into one of the treatment groups. So you'll need to talk about why this would be a problem. So, here's the thing, I will say this, number 2, you don't fully know yet, don't sweat it, do what you can and think about it, we'll talk about it on Monday. That's where we'll pick up.
Who should call me?
Let's all FaceTime guys.
Yeah, let's have a-
Yeah, what's the problem with having all the seniors in one group? Yeah.
We're on each other.
Study this weekend.
Kinsey, me
Yes,
first.
please, come in early on Monday. Where's your card, Pete?
Thank you,
I
Star.
won't have morning meeting next week, so. Oh, thank you.
King.
Kings. Thank you.
Yes, I did.
Bye, Kenny.
Fours.
Bye, Kenny.
Fours. Bye, whoever said bye.
Oh,
Star, I think maybe.
bye. No, I said it.
Hello.